Welcome back to this course on symmetry, stereochemistry and applications. So, let us start the lecture today from the point where we stopped in the last class. We were trying to understand the nomenclature of various organic molecules. So, in that I had given you one small problem to identify the name of a given molecule. So, what I gave is this particular molecule. I said, keeping the rules that we have already discussed, we try to identify the name of this molecule. So, let us see what the solution is. So, what we should try is, we should first try to identify the longest chain in this molecule. So, when you try to see that, what we find is, if we are trying to number it from the either side, either from the left corner or from the right corner, we get the same thing like 1, 2, 3, 4, 5, 6, 7, 8 and 9. So, it means that the molecule is a 9 carbon hydrocarbon and it is called then non-N. Now, we need to find out the substitutions that are present. So, what we see very easily that there are two groups that are attached. One is at number 4, a methyl group, and the other group at number 5, which is a slightly larger group, which is a propan 2-yle or isopropyl group. So, when you try to name it, we should start from the lowest numbering, where the 4 is methyl and 5 is isopropyl, or more appropriately propan 2-yle. So, the name of that molecule will be 4 methyl 5 propan 2-yle non-N. Hope you are able to follow this type scheme of nomenclature. So, when we are trying to identify the name of a molecule, what we need to worry about is first to find out what is the main chain of this particular molecule, what is the length of the main chain and how to number that. So, in this particular molecule that I am showing here, there are two possibilities of considering the main chain. In the first figure on the top, what you can see is I have marked with red the long chain, which has 1, 2, 3, 4, 5, 6, 7, 8 carbons. In the lower figure that I have shown, I have marked the longest chain using blue. So, you have 1, 2, 3, 4, 5, 6, 7, 8. So, now what we have is, in both the cases we have 8 carbon atoms. Now, the question is which one to take, which one is my longest chain, how do I number it? So, we need to add now a new rule. When you are trying to number a long chain in this manner, one has to look at the how many branches are there associated with a given long chain. So, what we see in this particular case, when we are looking at the top drawing, where you have the longest chain of 8 atoms drawn in red, you have two substitutions, 1 and 2, and in the lower case, if you look at the blue chain, we have 3 substitutions. So, when you have 3 substitutions in the blue chain, blue parent chain, then we must identify the longest chain as the blue chain and then try to write the name of that molecule in that fashion. So, when we try to write the name, we should write the atom numbers starting from left to the right, and then try to write down the name of the molecule using the appropriate prefixes. Those are the substitutions that you have on the main chain. So, now what we have is at 2 position and 6 position, we have 2 methyl groups. So, that we write as we have 2 methyl groups at 2 and 6 positions. So, this we write as 2,6 dimethyl. At 5 position, we have an isopropyl group, we have a propyl group. So, we write it as 5 propyl, and the main chain is octane. So, we write it as octane. So, the full name will be 2,6 dimethyl 5 propyl octane. Now, we need to worry about a new type of branching which we have not addressed before. The last kind of alkyl group which has a complex branch. Here what we mean by complex branch is complex branches are those that have no simple name, yet they still need to be named in a molecule. So, in this particular case, if you look at the branch that is drawn in red, this part is different from what we have seen before. So, we need to name this complex branch using a set of rules. So, when we try to do that, what we need is to find the point of attachment inside the complex branch itself. So, here what you can see in the red branch, you have a blue dot. That blue dot identifies the point through which this particular branch is attached to the main chain. So, now considering that blue point as the point of attachment, we need to identify the number of carbon atoms present in the longest chain in the complex branch. So, starting from that blue dot, we can write the longest chain as 1, 2 and 3. Remember that we should write that as 1, not the chain that comes like this as the longest chain. So, what we do is then we try to write the name of the complex branch. So, when you have 1, 2 and 3, identify the other prefixes that are present here. So, in this particular example, there are 2 methyl groups attached. So, when you have 2 methyl groups attached in this branch, we should write it as this group will have a name written here. At one position we have 2 methyl groups. So, we write it as 1,1 dimethyl. Propyl is the name of that chain, and this complex branch is attached at the 5 position of this molecule. So, we write it as 5 in square bracket 1,1 dash dimethyl propyl nonane, and this is the name of this particular molecule. So, this is how one should name a complex branch in a given hydrocarbon or in a given molecule. Now, let us move to the next part where we try to name the cyclic compounds. When we are naming the cyclic compounds, we need to first determine the ring size of the parent and whether the ring parent is the ring or any other part of the molecule is the parent. If the ring has more number of carbon atoms than any of the alkyl groups attached to it, then the ring is called the parent ring. If not, then the ring becomes a cycloalkyl group and is a prefix to the main chain. So, we should remember this. So, when you have an example like this, where you have a small cyclobutane attached to a large hydrocarbon. The chain is the parent and the ring is the prefix. So, in this particular case, when you have a cyclobutyl ring attached to a chain, we write it as 1 cyclobutyl octane, because the parent, the chain, has more number of carbon atoms compared to the number of carbon atoms present in the ring. Now, we continue in the cyclic compounds. Now, in this case, you see here the situation is opposite. You have a molecule where the ring has 5 carbon atoms and the side chain has 3 carbon atoms. So, 5 carbon atom ring is the parent and the side chain is a prefix. So, like that, when we try to name the molecule, we write it as propyl cyclopentane, and this is the name of this particular molecule. What we need to remember here is that we should not double count the atoms that are connected to the side chain. The side chain is starting at this point of attachment. So, from here the side chain is attached. So, the side chain length has to be considered from this side to the other end. We should not count that atom through which this side chain is connected along with the number of carbons in the side chain. We should not count that atom twice. Now, we need to see what happens when we have multiple groups present in one particular cyclic compound. What we need to do is, we then need to give numbering, and those numbers should be such that the sum of the numbers coming on the substitution should be minimum. So, for example, in this particular case, the way is written here is one way of writing it. I can write it as 1, 2, 3, 4, 5 and 6. So, in this particular way, when you write the number in yellow, what we see, the sum of those two numbers becomes 1 plus 5 equal to 6. So, that 6 this number 6 is larger than 4. So, the way that was numbered in red is the right way of numbering. So, 1 plus 3. So, when we write the name of the molecule, we should write it as 1,3-dimethyl cyclohexane. How about this particular compound? How should we name this molecule? When we have 3 different functional groups, 3 different prefixes, we again write the numbers in such a way that the sum of those 3 numbers is the lowest. So, here we write it in the anti-clockwise direction, starting at 1 to 2 to 4, and the sum is 1 to 4. If we had started from the point 2 and written it in the other direction, then what you would have got is different. If you had started from here as 1, 2, 3, 4, 5 and 6, in that case it would have been 1 plus 2 plus 5 equal to 8, which is larger than 7. So, as a result, the name should have been different. Now, we have another possibility. We have 2 different groups attached to a cyclic compound. So, when we have two different groups attached to a cyclic compound, what we need is we need to prioritize them using the first alphabet of the name. So, we should alphabetize each of them and we should try to write the name of that compound. So, look at the molecule here. It has on right hand side a 2 carbon atoms, and the left hand side it has 3 carbon atoms. The groups are different. One is isopropyl and the other one is ethyl. So, when we try to write the name of that compound, we have to number it in such a way that we get the lowest sum. Now, in any direction, if you write methyl as 1 and isopropyl as 3, it is 3 plus 1 4. If you write isopropyl as 1 and ethyl as 3, then it is 1 plus 3. So, that both way it is the same. So, while trying to name it, we should again alphabetize to give the number, and we assign number 1 to the ethyl group and then number 3 to the propan 2-yl group or the isopropyl group, and we write the name as 1 ethyl 3 propan 2-yl cyclopentane. Hope you are able to follow this type of nomenclature. So, we continue the understanding on cyclic compounds. See here, I am giving you a few examples. What is happening here? Can you see the number of carbons that are present in the ring and the number of carbon atoms present outside the ring are one and the same, and the way we have named this molecule is unique. So, in the case of the first molecule, where we have a cyclobutyl ring and we have a butyl chain attached to it, we have named it as butyl cyclobutane. That means the parent is cyclobutane and butyl is a substitution. Similarly, second one we have written as butan 2-yl cyclobutane, the third one as tert-butyl cyclobutane, this one as pentyl cyclobutane, this one as pentyl cyclopentane, and the last one as pentane 2-yl cyclopentane. So, what is the logic behind this type of writing? The logic behind this type of writing is that the group cyclobutane is unsaturated hydrocarbon. So, the unsaturation gets priority over a saturated chain. So, the unsaturated chain gets the name of the parent and the side chain is written as a prefix, and that is why when the outside and inside, that is the ring and the chain, has the same number of carbon atoms, the name is given with the cycloalkane as the parent and the other part as the prefix. We have one more such example which has a complex branch that you can see, and again the complex branch is named as we have understood in this class a few slides before. So, here we have the side branch which is connected at this point. So, here we write it as 1, 2, 3, and then we have 2 methyl groups, and those 2 methyl groups are named as 1,1-dimethyl propyl cyclopentane. Now, in a cyclic compound, as you know, it is a ring molecule, and when you have a molecule which is a ring, it is possible that the substitutions that are present on those 2 carbon atoms can both be up, can one be up and other one be down. So, when you have such conditions that 2 alkyl chains or 2 groups attached to a cyclic compound are spatially oriented in different ways, either both are upwards, pointed upwards, or one pointed upwards and the other one pointed downwards, we should identify those two molecules as two different molecules. And when we try to write that, we try to understand them in the form of cis and trans. When the two groups are pointed in same direction, it is called the cis. When the two groups are pointed opposite side, that compound is called the trans. So, when we try to draw that in a two-dimensional projection using wedge and dash formula, when you write this type of wedge, this type of dash formula, and that identifies that this is a trans molecule. So, when you have such a molecule, you try to write down the name as 1,2-dimethyl cyclohexane, and when we see that the two groups are on the same side, we add a small term as cis, the prefix to a prefix, which is cis 1,2-dimethyl cyclohexane. Now, let us move to the next set of molecules, which are the alkenes, where you know that there is unsaturation. So, there will be a CC double bond, and they are more reactive than alkanes due to weaker pi bond, and they are called unsaturated hydrocarbons and do not contain the maximum number of hydrogens that are possible for a given number of carbon atoms in an hydrocarbon. So, in that also we can have a cis and trans different isomers, and here in this particular example, where you can see on the top you have a CC double bond in the middle, and that CC double bond has two methyl groups attached, and both of them are on the same side. So, we call that as cis butene, and the other molecule that you have in the lower bottom end of the slide, you have a double bond, and the two methyl groups are across the double bond on two sides. So, this molecule is called the trans 2-butene. These things are actually taught in your 10+2, but I would like to cover this as a follow up, because you may have forgotten many of the things that were learned in your 10+2. So, when we have a CC double bond, and if there are 3 or 4 different groups attached to a double bond, then we try to write them as E or Z instead of cis and trans. So, E in German means entgegen, and that means it is in opposition to, which is equivalent to trans, and Z in German is zusammen, which means together, which is equivalent to a cis. So, this nomenclature can be found in this particular link, where you can get all possible rules of the CIP nomenclature of organic compounds. So, here what we can see in the molecule, these two molecules have same formula, but the groups that are attached are in different way. So, both of them have 5 carbon atoms in the longest chain, and the groups that are attached in different directions. So, what we see here is that we try to prioritize the position of the atoms on either side of the double bond. So, in the upper molecule, the hydrogen atom is attached here. So, on the upper molecule, the priority on the carbon number 2 is for the methyl group, and on third carbon, the priority is on the ethyl group. So, here the two most prior groups are on the same side, and it is equivalent to cis. That means in the EZ nomenclature it is Z, and this 2 that appears is the position of the double bond from where it starts. So, we write it as 2Z 3-methyl pent 2-in. In the lower case, the first higher priority methyl group is down, and on the other side the higher priority methyl group is up. So, these two are in opposition to, and that means it is Endgegen or E. So, we write it as 2E 3-methyl cyclopent 2-in. So, this is how these two molecules should be named, and they are different, as you can easily see. So, here are some more examples of a double bonded compound. You can see the names of these molecules. The first one is named in such a way that you have the double bond between 1 and 2. Second one, the double bond is between 2 and 3, and in the third case the double bond is again between 1 and 2, but on the other side, because the position of the double bond, when it changes, it decides the way it should be numbered. So, functional group has higher priority than branches. So, in this particular case, when you have the first molecule, it is 1-in. In case of the second molecule, it is 2-in, and in case of third molecule, it is once again 1-in. So, the in gets higher priority over the functional group, and then in gets priority over the branches. And now, in case of first case, when you have written it numbering from the left hand side 1 and 2, the alkyl chain is coming at the 2 position. So, it is 2-methyl but 1-in. In second case, we write it as again at a 2 position you have the substitution. So, that is again 2-methyl but 2-in, but in the third case the substitution that comes is at 3 position. So, we write it as 3-methyl but 1-in. So, with this we will end our lecture here, and we will continue from this point in the next class. Thank you.